In the previous video, I showed you how to do state hoisting with a simple technique, moving the state out of a composable to its color. But what if you want to hoist the state to a view model? So nowadays, a lot of people are using ViewModel in their Android applications. How do we do that? How do we state hoist to a view model? So let's switch to Android Studio, see what we have. So I have a simple state hoisting from the previous video, and I'm gonna change this hoisting to a view model. So first I'm gonna create a view model. So in this file, I can create my view model by defining a class and view model, but before that, you need to make sure that you have the required dependencies for Compose in order to interact with ViewModel. So I'm gonna switch to build.gradle file for the app module, not this build.gradle file. I need the other build.gradle file. And I need to add two dependencies. Implementation. One of them is Compose integration for ViewModel, and the other is Compose integration for live data. So first, the ViewModel Android X lifecycle ViewModel Compose, and because I don't know the version, I use the minimum version to trick Android Studio to help me. Alpha 1. You can also check the latest version on developer.android.com. Change to 1 Alpha 3. Android Studio tells me the latest version. So this is the first dependency, and the next one is live data. Implementation Android X Compose runtime live data, and 100 alpha 01. Again, I ask Android Studio to tell me the latest version. Yeah, the latest version is 1 beta 2. So I press Alt and Enter and change to that version, and I press Sync now. We wait for the project to add these dependencies to our application, and that's done. I close these build files and switch to main activity. Previously, I told you I want to create a view model inside this file, but it's more beautiful to create it in another file and not in main activity. So I'm gonna switch to project view, and here I'm gonna create a new file by right-clicking and then selecting new Kotlin class file. And since this is class, the type is class, I name it count view model. I'm not gonna make it very complicated. It's just supposed to change and store the value of count. Okay, I create a variable for it, a field for count, and because this is a view model, this is supposed to hold a live data for us. So private val count, it's a mutable live data. I import it from the lifecycle library, and I pass it an initial value of 0. And then I create another variable to read the value of underscore count, and in fact we will use that to read the value of count, but we will use this one to set the new value of count. This is a simple trick that we often use with live data. So val, note that this one is not private because it is supposed to be accessible. Val count, its type is live data, and its value, let's import live data, its value is count. It's not empty live data, it's live data of the type integer, because the type of count is integer, as we know. Also, we will have a function that we will use to tell our view model to change the value of count to a new value. So I define a new function, fun on count changed. Note that this time I'm calling this function on count changed because this is supposed to change the value of count, and here the value of count is actually changed. The previous ones, the on count change functions that we created in our main activity, like this one, in fact we're supposed to only signal and request a change in the value of count, but this time we are actually changing it. This is the core of change, this is the core of our state and the source of truth for our application. This view model is our source of truth. So this receives new count, so define a new parameter for it of the type integer, and its operation is very simple. All it has to do is set the value of count to new count. Alright, that's all we need in our count view model. I return to main activity and see what I'm supposed to do to hoist the state to my new view model that I just created. So because I will read the state from the view model, I don't need this definition anymore. So I comment it out to later remove it. And first I create a view model. Val count view model. I define a new variable, count view model, I name it. Its type is count view model. And I create the view model, the count view model instance by calling ViewModel. This is a function, a convenience function in Jetpack Compose that allows us to create view model in the scope of our current activity. Our current activity, main activity, has a scope, and in its scope, this function will create the view model, count view model, and return it to us. And in fact, you can see that in the inline documentation, it returns an existing view model or creates a new one in the scope, usually a fragment or an activity. Alright, so we have our view model, and from the view model we need to read a state. What is that state? That state is count. So I create a count, I say count vm dot count observe as state. So this will return a state for us, but make sure that you also specify the initial value for it. The initial value is 0, like we created with mutable state of. We passed in an initial value, so make sure you pass that here as well. So now we have the count, and we are passing it to box screen. But in order to access the value of this state, we need to use delegates. So I remove this equal sign and make it a delegate, and now it returns the value of the state, which is an integer and is compatible with the signature of box screen definition. Also, we have the handler defined inside our view model. OnCountChanged. So we can use it here when we need to change the value of count in our view model. So whenever count changes, whenever we want it to in fact change, we call that. We say count vm.onCountChanged, and then we pass in the new count. Just like this. It was simple, huh? So I think that we are good to go. Let's comment out the section for preview box screen. In fact, it doesn't make a difference. It will work anyways, but I'm gonna comment it out so that you know you should switch to ViewModel here. And I'm gonna run the application, and we are expecting the application to work just as before, but we know that behind the scenes we have hoisted the state to a view model. Run the app again. There was a crash in our application. I run the app again. There was something wrong. Let's check the dependencies of our application, build.gradle file, or before that, let's check the logcat. Cannot be cast to Android X lifecycle view model. Sorry, I had a mistake in defining the view model. The view model, when we define it, the view model class has to be extended from Android's view model. So make sure that you extend your view model from Android's view model, which is from the lifecycle package. So I import it, and also make sure that you are using the constructor invocation here by adding a pair of parentheses, and now our code should work. I run my code again. And there we go. Our application is running successfully. Increase 1 by 1 is added to the list of our child boxes, and by pressing decrease 1 by 1 they are decreasing. Beautiful. So in this video I showed you how to do state hoisting through a view model and hoist the state of your composable to a view model. This way, having a central place for managing your state and a central source of truth. So the general idea for compose is that data or state always flows down to the composables from the parent to child composables, and events flow up. So you can see that we are flowing the state value of count down to a composable, and that composable is invoking events up, and the color that called that composable above is responsible for changing the state, but not the composable itself. The composable should usually have no direct access to changing the composable's state. So again, data flows down and events flow up. Alright, that's it for state hoisting to a view model. I hope that you liked this video.